Alright guys, welcome back. So far we haven't talked about permission. And permissions, this is a pretty important topic regarding to app hacking. So therefore, let's do this over here. Let's find out how the Android system is handling those applications, or even better, sandboxing them. So every application on the Android system is generally being sandboxed, which means application 1 cannot simply access the data of application 2 and application 3. And this is good. Imagine having an Android system where every application can access the data of each other. This means a third-party application could simply access our banking data. This would be horrible. Or for example, our photos, activating the microphone, taking pictures, stuff like this. So this is something we do not want to have. So how is the Android system handling all this stuff? Well, it might be easier than you think. We're having a Linux system, and the Android system is simply just assigning a single user for every application. This is the whole magic behind this. So every application gets its own user ID. And this simply means if user 1 wants to access the data of user 2, this will be simply denied. These permissions are being defined in a file, in this one, in platform XML, which is stored under etc permission. So here we're having a file containing most of our users. We will learn that not all can fit into this one, but more on this later. Okay, so this file defines our user IDs, and this is being individual for every application. Alright, but now we're having the case that application needs to exchange data between each other. This could be, for example, accessing the photos, or accessing the microphone, geolocation, or for example, exchanging data between other applications based on content provider, broadcast receiver. We will learn more about this later. So how is this being done right now? Well, we could simply add user 2 to our app 1, for example, based on groups. So this user 2 will be now added to our application 1, which means we are now having also access to the data of application 2. For example, photos, microphone, camera, stuff like this. All of this is being defined in the packages.xml file. So after adding a user to our application, this permission will be inserted over here. And it's also being tracked if the user has been granted this permission or not. Alright? Okay, so far so good. We are having individual users, and we can also add users to other applications. Both of them are defined in those files. But now we're having some system users, and those users need to be active before the system is running. And these user IDs, for example, the ADB shell, these will be hard-coded into a kernel file, in this one over here. So there will be defined that some users have some predefined IDs, and they are not stored in those two files above, and also where those user applications start, for example, at ID 10,000. But this is not that important right now. The important things we care right now is the packages.xml file, because this file gives us access or even denies us the access to those permissions. Alright? Okay, so far so good. But now's the question, how can we ask for a permission? This is the most important part. How can we access photos, camera, microphone, stuff like this of our Android system? And the answer for this one is being defined in the Android manifest XML. We have already seen this in the Android manifest before, but let's recap this real quick. So this is a configuration file, and in there we define all our permissions we want to access in our application. If we haven't defined a permission in there and we want to access the data, then the application will crash, which means we cannot simply circumvent this until we're having, for example, root privileges or an exploit like Dirty Pipe. Dirty Pipe is a race condition where a socket can write into a process which should be only able to read, and this could be abused to override a certain configurations file, for example the packages.xml. But unless we are not having an exploit or root privileges, we cannot circumvent this. So we need to define our permissions over here. Alright, if we define those permissions, these will be added into the packages.xml. And for example, over here we have read context, internet, and read external storage. So these single user IDs will be defined over there. They will be simply added. And also there's some kind of tracking if the user has granted those permissions or not. So this is how the Android system is handling this stuff. Pretty nice, right? Absolutely. And so far everything seems to be fine. And regarding to the core system permissions, it is fine. But what developers sometimes underestimate is custom permissions. And this can be absolutely ridiculous. And we will also have examples regarding to this one. So For now, if you fell asleep, no problem, but now you need to wake up because now it's the interesting part. Okay, so you woke up? Perfect, because now we talk about custom permission, and this can be your pony under the Christmas tree. So what isn't custom permission? I mean, applications can exchange data between each other. For example, app 1 can share data with application 2. But let's say these data are a little bit critical. For example, it could be a one-time password or a TAN message from your banking application. So therefore, you want to make sure that those data are being protected and only application 2 is able to access them. How is this being done? Well, with a custom permission. And so far we haven't talked about those 4 key components: activities, content provider, broadcast receiver, or services. But I mean, it's also not that relevant right now. We will do this later on extensively. For now, we only need to consider that those are possibilities to exchange data between each other, and this is being defined in the Android manifest XML. Okay, so far over here we are having our application 1. This has now a custom permission, and now we need to be very precise on this one. The custom permission, if it's being defined over here, does not start with uses permission because it doesn't use this permission, it's defining this one. So if you find this tag permission, then we are having most likely a custom permission which is being defined in this app, which means this permission is protecting something in this application. Over here we can see we've got this permission, then we've got this Android label. This is, by the way, from the Seev application, which we, I guess, have seen so far. Otherwise, we will also have a look into this one, but back to this one. So this permission over here is being defined, and now we are having a label, allows reading of the key in Seev, Android name, this is the name of this permission, and then we've got a protection level. In this case, dangerous. And this is also a little bit misleading, but more on this later. Okay, so here we have our first custom permission. And this one it's telling us allows reading of the key in Seev. So the key, it's a table. Yes, it's a table. And this table contains our passwords. And if an application has this permission, it can access our passwords in our Seev application over here. All right. This permission is being defined over here. So this is something like, for example, like the contacts permission, where we are using this uses permission contacts. Over here, we are now defining a complete own permission right now. Okay. Underneath, we have another custom permission. Here we have permission, Android label, allows editing of the key in Seev. And this means we can write to this table right now. This is the name. Here we have now write keys. Over here it was read keys, now we're having write keys, and here once again we have this protection level. Okay, this means the application 1 can provide data to all applications, but only the ones having this permission, this one over here, are allowed to interact with these data. Alright? If not, I guess this is absolutely no problem, because when we talk about content provider, and we do this pretty extensively, then this will be a little bit more clear right now. So now is the question, how can we as a third-party application or as an attacking application can get those permissions? Well, we only have to define them in our application. So over here we can see we can simply tell users permission, and then instead of contacts, photos, microphone, we simply define those custom permissions of application 1. And now if we have defined them in our application 2, we can simply ask nicely, can I read your keys, which means your passwords, credentials, stuff like this. And this application is now responding back, yes, you asked that nicely, you are allowed to do this. So a custom permission is not being a real protection for this one. So you cannot protect your data based on a custom permission unless you choose the correct protection level. But now's the question, what is the correct protection level? So far I can tell you, dangerous, it's not. So what are those options we have as a developer? Well, we've got the following. We've got dangerous, normal, signature, and signature or system. But signature or system is something we cannot use in our own apps. So therefore we only focus on dangerous, normal, and signature. Alright, protection level dangerous simply means the user needs to be informed about this, but this is all. And then the user can make the decision if our application is allowed or denied to access the contacts. I mean, yes, if the user denies everything, then we are not able to read out the stuff, these contacts or maybe the keys in the custom permissions. But I mean, relying on a user decision if some critical data can be accessed, I guess that's not the best idea. But I mean, it's even better than normal, because normal simply means we are not being informed about this. So that's another protection level. For example, if we are using the internet permission. This permission is not being displayed anywhere. It's simply automatically being granted. But I mean, yes, of course, we cannot simply use the protection level normal for some high sensitive permission like camera or microphone, for example. But this is something we do not have to bother about, because this is being done by the Android system, unless we define our own custom permission, because then we are in charge of this. And if we would choose normal for some high risk permission, for example, accessing these databases, keys, passwords and stuff like this, then this would be definitely a finding. I mean, every application could access our data without the user being informed about this. This would be bad. So normal is definitely not the right option for sensitive permissions. But I would also say dangerous, it's really not the best case. I mean, we are outsourcing such an critical task to the user, and this is something we should handle as a developer. Alright, so what is better? The best option would be signature, but there's a little bit of a downside regarding to this one. Signature means every application that has been signed with the same key can access the data. So this means if we write our own third-party application and try to access, for example, this keys database, and this has been protected with the protection level signature, then we would need the private key of the application owner of Thief to access this data. And of course, this is something we do not have. And this is also the downside regarding to this one right now, because protection level signature, I mean, this is the best approach. But I mean, we cannot share our private key. This would be more ridiculous right now. And therefore, this might not be practical in the daily business. And therefore, most of the time, we have to deal with a protection level dangerous, which means the user is being informed about this, which is good. But if the user misclicks over here, then all these data are being gone, which could be absolutely bad for the user right now. Alright, so this is everything we need to know about permissions in a nutshell right now. It was a lot of theory, and therefore I would suggest let's recap this on a practical view on our Ubuntu VM. So let's dive into those permissions file. Let's see what's inside there, and yeah, let's recap this a little bit. Alrighty? Okay, so I see you on the Ubuntu VM. Alright, here we are back at the Ubuntu VM, and now let's have some practical view on the whole topic. So we start with the pre-configured user IDs in our Android system. And these are being defined in the Android file system config.h. So within our kernel, we cannot simply access this in a file over here. We have to take a look into the Android source code. So let's do this. So we are simply searching for Android file system config.h in the browser of our choice, in the search engine of our choice, and here we get the Android Google source code. So let's open this one, and here we have it. So this is a predefined list in our kernel, and this is defining some user IDs. For example, the AID system has the user ID 1000, radio is 1001, and so on. I mean, this can change depending on the manufacturer and the Android system we are using. So here we can see this one is for version Android 4.2. I guess regarding to our Google Pixel, this is still the same. So the Bluetooth, I guess, still has 1002 and so on. But nevertheless, I mean, if you want to be more precise regarding to our device, then we have to look for the exact version and also the exact model and manufacturer. Okay? So for now, we stick to this one. Alright, here we can see the camera has this user ID and so on. Let's scroll down a little bit. Yes, ADB shell, this one over here. This is the ADB debug shell, and this is the user ID 2000. And let's verify this. If we open a new terminal and making an ADB connection, typing in ID, there we have it. User ID 2000. Perfect. We can also see, for example, net BT might be Bluetooth, admin 3001. Yes, exactly what we can see over here in this one. Alright, and then we've got a bunch of other stuff, and this one is also pretty nice. Here we can see this is our first user app. So our user application starts at the user ID 10,000 and it simply goes upwards. This is just the definition, okay, User IDs start at 10,000 and every time we install a new application, this value will be increased. And let's see. Therefore, let's keep it open. Okay. Therefore, we switch into the data directory. And if we perform an ls-l, then we have no permission. So we switch into the root context and do this once again. And here we have this. So let's see, do we find some user applications? This one, for example. This one is the com MWR example Sieve application. And this one has now this strange user ID. So that's the user ID and the group. So here we are having u0_a129. This is now some kind of alias. So our user ID for this application is 10,129. So we can substitute the A with a 10,000. We could also verify this within the package manager. So the package manager, I guess, has an option for this one. Let's see. Yes, over here. So here we can see with the -u option, we can also show the package UID. If we go up once again, we have talked about the Sieve application, which has the user ID 10,129. This A can be substituted. So let's do this. So let's see if this is correct. We are using PM, list packages, and this time with the -U option. This one. Okay. List packages, U. Oh, the package manager, of course, in front of this. Here we have it. And now we've got all these user IDs behind this. And if we do not want to search for Sieve, then we can also grab this. And there we go. There we go. Okay, we have an hacking application already there. And you can also see we are doing something with logging bypass. But this is our Sieve application. So maybe let's do it this way. The exact package. Okay, let's clear this. There we go. So you already have a little bit of a spoiler, but we're going to do further in this course. But for now, we can see, yes, we are having the user ID 10,129. And if we scroll up a little bit, we can see that every application has its individual user ID. All right. And this is how the sandbox is being implemented. Every application gets its own user ID. So far, so good. So now's the question, where are those user IDs stored? I mean, here we can see them, but where are those being defined? And this file we have seen in the theory part, but let's have a practical view on this one. This was the etc permission platform XML. Yes. I mean, it's a little bit hard to read, but I guess it's still fine. Let's scroll up a little bit. There we go. So here we can see, for example, the Android permission internet has this user ID shell. Oh, okay, interesting. Then we can see modify audio settings has this user ID audio server. And this is being packed together. So audio server, I mean, it's some kind of alias for this user ID, like this A129, I guess, regarding to our Sieve application. So therefore this UID over here, it's some kind of alias for this. And we can see the audio server is being packed together with all these permissions, which means if we grant this user ID to our application, we have access to all these permissions over here. Pretty cool, right? Let's scroll up a little bit, but I mean, yes, there's a lot of stuff in here. For example, read logs. This has the group ID log over here. NetAdmin, internet. There we have it. That's the group ID. And over here, yes, here we have the user ID. All right. So yes, I guess that's the interesting part over here. All right. So this file contains our user IDs and group IDs. All right. But still, we do not have this matching. So here, those core permissions are being defined. But now if we ask for one, how is this being added into our application? Well, this is being defined in the packages XML. And this one is within data system packages XML. Yes. So this file contains all necessary information for our application. For example, the signing key, permissions, and stuff like this. But I mean, let's simply have a look into this one. That's why we are here. Okay, yes, so that's a lot of stuff. So therefore, let's copy a little bit out into a more readable format. All right, here's the beginning. And then let's open Visual Studio Code, because there we have some XML highlighting. Yes, so here we have this packages XML, and we can see the Google Authenticator is using a lot of stuff. So therefore, let's not focus on core Android applications because they have lots of permission. Let's stick to our Sieve application. So com MWR example Sieve. Here, for example, we can also see this was the custom permission we have seen in our Android manifest XML, at least on the theory part within the slides. So this one is of course also being an permission defined over here. So as our contacts permission, we can now ask for this one over here. And we can see protection is being set to 1, which was the protection level dangerous. All right? Okay. But for now, let's stick to let's go back to our Sieve app. Over here. Okay, and we can see, maybe let's enable some word wrapping that we don't have to scroll. Okay, now we have everything here. Okay, this is our package name, our individual identifier for this app. Then we've got the code path. So this is base64 encoded, but I mean, there's no real value behind this. We can simply access this directory. Maybe let's do this by inserting all these strange characters. ADB shell first. Yes, so you can see this is a real directory path right now. Okay. So then we've got our library. So this, by the way, our APK file. And then we've got some libraries. Okay. Some other stuff which is not that important. Here we have the user ID 10,129, exactly what we have seen in our listing. And then this one over here, this is the certificate, and I mean this one needs to be included over here regarding to the protection level signature. Protection level signature means we can give access to other applications that have the same signing key, and therefore this one needs to be stored over here. If we now provide this protection level, this file, this packages XML file, has track of this one and can make the decision of application 3 if this one is allowed to access the data or not. Alrighty? Okay. And then we've got these permissions which this application is using. Here we can see permission internet, and this one is flags 0. So this is the protection level normal, which means no certain user pop-up or other stuff is being required. It's automatically being granted. And in case if we would have granted more permissions, then they will be also listed over here. Let's go to another application. Let's see. I guess our SpacePang application should be also here. SpacePang. Oh, unfortunately not. Then Insecure Bank. Yes. So here we can see this is another app. It's another capture the flag application. And this one, I mean, the structure is the same. We can see all the stuff over here, the Android app path, which is this one, the package name, native libraries, signing key. And this time we can see this app is using use credentials, reprofile internet and network state. And we can also see if those permissions has been granted or not. If we have root privileges, I mean, we can add all those permissions and we can set this to true or false, however we like. But if we have root permissions, I mean, then it's not required to access certain permissions in an application. Then we already have access to everything. All right. So if you want to add and let's say add all of them over here, yes, with root privileges, this would work. Or for example, with the dirty pipe exploit, this would also work, which might be a little bit more interesting right now. But I guess if you can override or modify those system files, then you can achieve everything else without modifying or accessing or entering some new permissions over here. Okay, so this is all right now regarding to permissions. I mean, we have seen, if we go back to this one, within our data directory, every application will be assigned to an own user ID. This user ID can be fetched via the package manager or within the packages XML. Or if you're talking about core Android users, then within the, what was it? Yes, the platform XML file. So this is how our permission sandboxing concept works, which means this Sieve application over here has this user ID, and therefore it's not allowed to enter the data of this app until we give this permission, for example, for a database. This could be done via a content provider to access the data in a database. If we provide this in a custom permission, and this application is using the custom permission, then we are allowed to access those data. So this is what we have seen over here. Read keys. Where do we have it? There we have it. So this is a custom permission defined in the Sieve application. Remember on the Android manifest XML, I will blend it in. And if we assign this permission to our app, then we have to check the protection level. If it's dangerous and pop-up might occur. On older versions of this app, this might not be the case, but on newer version, a pop-up will definitely appear. But if the user grants this access, then we can interact with this app. Alrighty? Okay, if not, don't worry. If you talk about content provider, it will make snap and this part will be crystal clear. I'm pretty sure about this one. Alright, so now this is really all for this video. In case if you have any questions, drop me a message under the comments, and otherwise I'm looking forward to see you in the next one.